Alright, so this guy's a 6.6. Rational exponents. Let's go. A rational exponent. It is an exponent. That is a fraction. Surprise!
Do you write all this down?
No, summarize. Okay, so for example, 27 to the 1/3 power, you can rewrite it as the cube root of 27, which eventually gets up to be 3. Okay? Basically, knowing how to translate from one form to the other is the most important thing up there. Okay, we're going to start with a couple of examples. Do that after I ramble for a couple minutes. The index and the denominator, that's the key. Okay, the index is your denominator. When you go from one to the other, that's the correlation. The index and denominator of your rational exponent are the same thing. Alright, now, to be quite honest, to be 100% honest with you guys, I prefer to think of everything in rational exponents. I do. Whenever I need to write problems, or once we get past 6.5 into 6.6, my head it doesn't hurt as much. Because now we're out of radicals and we're to rational exponents, and this will help make, hopefully, your last section kind of make sense on why stuff works the way it does. Because you have to know both. Yeah. So, there's two different variations to these whenever we're going to work with them. There's one like the top box that has numerators of 1 on the exponents, and then just very simple, 27 to the 1/3 is the cube root of 27, or 3. And they like to be mean to you on this one. They give you i's, which I won't. Okay, we're done with i's, I think, for the year. All right. So negative 16 to 1/2 power is the square root of negative 16, or 4i. All right, but like I said, you won't have i's in this section. Okay. They get a little tougher once you move into different powers on your radicand or your quantity. There we go. Because those now have numerators. So for down here, for example, if it was 27 to the 2/3 power, your index stays your denominator, so your denominator is 3. But then the whole quantity is what gets squared. Okay, so they're doing the cube root of 27 quantity squared, which once you simplify that down, becomes 9. Okay. The first 2 slides, if you're looking ahead, are basically ones where we translate from rational exponents to radicals and then back the other way. We start with that. And then we move into some of the simplifying. And a lot of this section has to do with 2 different sets. Okay, 2 sets of rules. Your first set is your normal exponent rules. Okay, power to power, product of powers, product of bases, stuff like that. What you do with your normal exponents, just like it was old problems from chapter 5. Okay? That's the first set of rules. Second set of rules kind of goes with what we were talking about the other day with how you rethink numbers. Okay, retraining your brain to see 27 as 3 cubed and not just 27. To see 9 as 3 squared and not just 9. Stuff like that. If you can do those 2 things, this section's not too bad. So we're going to translate these. We're going to write the following into exponential form. So your index becomes your denominator. So all you do for the first one, you have the 4th root of z. It becomes z to the 1/4. That's it. That's the answer. Yeah, changing forms. You go from the 4th root of z to the 1/4. So the 8th root of z becomes z to the 1/8. Right, nice and easy. Now remember, your denominator comes from your index. Any powers on the radicand go to your numerator. So the last one there is going to be c, a denominator of 3, your numerator of -5. Your index stays, your denominator stays with your index. Those 2 correlate. Any extra powers are in your numerator. Okay, Mr. Main?
So like if it's like the one that exceeded the -5th, will the number next to like c or z always be on top?
Yep.
Okay.
Yeah. Okay. knowing how to go from this way is probably more important, okay? To be honest with you guys, chances are, on about 95% of these problems, I'm going to give it to you already in rational exponents. Okay? I'm already going to give it to you there and say, all right, do stuff with it. Okay? You won't have to change forms a whole lot. You might on like a question or two, and you also might have a couple questions where I just want to make sure you can actually do it, you know? Okay, so it's not like you have to like switch forms and then switch back and then switch back. There's one that I'm thinking of that we're going to switch like one time. Okay? Alright, kind of same concept, just going the other way now. So you have x to the 1/6 power. You rewrite that as a radical, the 6th root of x. Okay, a to the 1/5 power, 5th root of a. Okay, the only ones that are a little tricky on this, and you really have two options, are your last one here, d to the 7/4 power. The 4 becomes your index, denominator is your index, and then you have d. The 7 on the power, you can put it in two different places. You can put it on the quantity itself, like that, or you could also do it on the inside. Technically speaking, either one is right. You don't have to show both, but either one of those is correct. Okay, like with most of these types of problems, whenever you're just simplifying, because that's all these directions will also say, is simplify this, simplify that, yada yada. There's a list of grading criteria I go by, and that's basically it. All right. An expression with rational exponents is simplified when all the following conditions are met. Number 1, no negative exponents. Never should you ever circle an answer with a negative exponent. Ever. Number 2. What?
So the one that we did, we had C.
Okay, except for just changing forms. You'll see what I mean by that.
So it's fine.
Yeah, that one's fine. Number 2 has no exponents. Pay attention to the words here. No exponents that are not positive integers in the denominator. So no negatives in the denominator, which has always been the case, but what else does that rule out then? If they have to be positive integers, they can't be positive what? Fractions. Because integers aren't fractions. Integers are your positive whole numbers, your negative whole numbers, and 0.
So if it's a fraction or...
So if it's a fraction or a negative in the denominator, you got to do something to it. Okay? It can't be like that. And we'll show you, and I'll show you why here in just a little bit. Okay? For you guys' purposes, number 3, it is not a complex fraction. It really doesn't come up a whole lot. Most of those are to be like split into 2 separate radicals. Okay, so that's not a huge deal on that one. The last one, though, comes up like one type of problem. Number 4, the index of any remaining radical is the least number possible. Okay, I ain't going to talk too much about that one, but once we get there, I'll kind of point out that that's where this one comes from. The index of any remaining radical is the least number possible. Your big ones are the top 2, those first 2. Okay, no negative exponents and no exponents that are not positive integers in the denominator. Okay, so kind of like how the first section of chapter 5, when we did all those big exponent rules, those 7 exponent rules, we had a list there. Okay, this is kind of the same deal. There's some different rules. Okay, and that's going to be a little bit of a change of pace today, because there's going to be some things we do today that you wouldn't think would be okay based on those rules. But now you follow these. Alrighty. Any questions so far? Everybody good? Anybody still writing? Ready to rock? Yeah. Alright, here we go. Number 1. Evaluate. No calculator. 81 to the negative 1/4 power. I said no calculator, Mr. Roach. Very good, sir. Way to put her away.
Which one's negative?
The negative power. Negative 1/4. No, one or the other. Let's say the top.
Doesn't matter.
Doesn't matter, but let's say the top. Okay? So there's a negative exponent. We see that, so let's simplify that first. What do you do? It's an exponent, not just a number. How do you change exponents from negatives to positives? Think back. No. You flip it down. Yeah. Flip it down. 1 over 81 to the 1/4 from chapter 5. Only difference now is it's a fraction that's there. Okay? Alrighty. So we're that far. Next step. Change your line of thinking. Rewrite 81 as a base number to some power. Oops. Get a little clearer. And that base power we want to be 4. Okay? Amanda. 3. 81 is 3 to the 4th.
You have to put the 1/4.
Yes.
Is that the answer?
No. Does you have power to a power? Everybody see that power to a power you now have? You just created? 3 to the 4th to the 1/4? Everybody see that? Okay. So when you have power to a power, what do? You multiply. So then what's 4 times 1/4? 4 over 4, better known as 1. So it's 1/3. Answer. Okay, so like I said, if the exponent's not negative, you don't have to flip it, so you can start with up top. So you're wanting to rewrite 216 as a number with an exponent of 3, which would be what? Yeah, good enough, 6. 6 to the 3rd, yeah. Alright, 6 to the 3rd to the 2/3 power. Okay, so 3 times 2/3 gives you 2, right? The 3's cancel, so you're left with 6 squared, which gives you 36. Done. Okay, Amanda. When you multiply bases, what do you do with those exponents? You add them. Don't overthink it. It's 8 to the 6/7. Now we're going to get a little tougher. Okay. We got b to the negative 5/6 power. All right. First step, same as with 81. We're going to flip that guy to the bottom. Okay. We're going to start there. I'm going to add a new problem down here, and it's a simple problem. Don't worry, it's not stressful. Okay. 2 over square root of 3. Technique-wise, what do you do? Not just like, what do you do? Like, what's the technique called? Roach.
You multiply by the times you get?
No.
Or,
Starts on R.
Rational.
You rationalize. Okay? You rationalize. Why do we rationalize? What can't be where it is? Amanda. You can't have a radical in a denominator. Alright? That's why we rationalize 2 over the square root of 3 by doing multiplying top and bottom by square root of 3, square root of 3. I thought I said delete you. Let's try again. Hey, there it goes. Alright? Now, remember where 5/6 as a power can go. It can turn into a 6th root of b to the 5th, right? Which means it's, in essence, a radical. Which is why you can't have rational exponents in your denominator. Everybody see? So we have to rationalize 1 over b to the 5/6. Okay. But the way we're going to do it is a little different. Okay. What type of numbers can we have as exponents in our denominators? Positive what? Positive integers. So what's the next positive integer up from 5/6? 1. It's 1. How do you turn 5/6 into 1? You add a 1/6 in there by multiplying by a b to the 1/6 power. Okay. It's basically rationalizing, but with rational exponents, not radicals. Okay, makes sense? Multiply your tops. 1 times b to the 1/6 gives you b to the 1/6. Good. 5/6 plus 1/6 gives you b to the 6/6 power, which is just 1. Okay. This is what I was talking about with how it's going to look weird. Okay, your instincts kick in here. All right, because you see bases happening multiple times, and I know I'm thinking the same thing. You want to try to get rid of them. You try to get rid of that b and turn those two b's into one b. You're just going to keep going around in circles. Okay. Your only move is either subtract these and go back to here and make it negative 5/6, or move this down and then make it 7/6, and then you're stuck again. So there's really nothing you can do with that question besides circle that. Okay, Cal.
Why? I'm just confused. The third problem that we did, it was this.
All right, next one. The 4th root of 27 over the square root of 3. Now, you have a 4th root and a square root. They don't go together. Okay, it's not like you can just subtract it and make it a cube root. Do the 4 or a square root. 4 minus 2 gives you 2. And oh, wouldn't that be nice? None of that crap. You can't do that problem until today. This is the one where it said make sure your indexes are as low as possible. This is what I was talking about. Okay, when you have different radicals or you have radicals of different indexes, you have to, before you can do anything else, change them to having rational exponents. Okay, have to. Okay, that's the first step. Change them to rational exponents. Now your world of possibilities is wide open. Okay. What's your next step, you think, Amanda? It's actually easier than that. Okay, it's way easier than that. Josh.
You just have to multiply by half.
Nope. Nope. No multiplication involved. Divide what? No calculator. Don't do that without a calculator. DeMarcus. Nope, can't do it with the exponents on there. Roach.
Do you change the 1/2
No.
exponent to 2/4?
Nope.
No? Okay.
You'll see it. One of these, you'll see it. Here, I gotta talk to Mr. Schumacher. Okay. X to the 7th over x squared is x to the 5th. How'd you get 5?
Well, you write that and cancel out the
That's the kid way. We're big kids now. How do you do it? Someone said it. You subtract. Okay. You subtract the exponents. Now, bigger question. Why can you subtract those exponents? Tenius?
No, because they both have x's in them.
They're both bases of x.
Oh.
Okay? They're both bases of x. So, taking that logic to our problem. 27 you can rewrite as 3 to the third. Good. Still to the 1/4 over 3 to the 1/2. 3 to the third to the 1/4 gives you 3 to the 3/4. Multiplying 3 times 1/4 over 3 to the 1/2. Now you have the same basis, so you subtract the exponents.
1/4.
1/4.
That's what I was trying to say earlier. With the,
Sure it was.
It was. I said 3/4. You have 3 over 3/4.
No, you don't.
No, for like the top number.
Last one. This one you use what you kind of the same line of things we've done in the past. All right, last section. It kind of looks like you might want to use a what? A conjugate. Good.
I want to.
See words.
Close, but not quite. All right, you have you have x to the 1/2 minus 2 over 3x to the 1/2 plus 2. Remember, that 1/2 power kind of represents a radical. And it's a radical in a denominator, which is not good. Okay, so we got to get rid of it. And since it's in a binomial, only way you're going to get rid of it is multiplying by its conjugate. Okay, so the conjugate of 3x to the 1/2 plus 2, x to the 1/2 minus 2. Top and bottom. Okay, now these are going to get a little nastier. Okay, yes, possibly nastier than what they had been. All right. Okay, Lindsay. How do you get 3x times x to be 3x squared? What do you do with those exponents? You add them. Or as Roach said, you add them. So when we multiply, when we do our first FOIL up here, when we do x to the 1/2 times 3x to the 1/2 on top, we're going to get 3x.
But no, I'm talking about like the x and the 3x, the x and the 3x to the 1/2. Wouldn't you have to square them?
All right, so that's your first FOIL. Now I'm going to show all 4 FOILs on top and bottom just so you know I'm showing my work nice and neat. All right, so x to the 1/2 times 3x to the 1/2, 3x. X to the 1/2 times -2 gives you -2x to the 1/2. Go to the next term, -2 times 3x to the 1/2 gives you -6x to the 1/2. Multiply your coefficients. Multiply your coefficients, add up your exponents. Last FOIL, -2 times -2 gives you? No. Plus 4. Gosh, Roach, think before you talk. Clearly. All right, now, like I said, the bottom I'm going to FOIL everything out, okay? So 3x to the 1/2 times 3x to the 1/2. The 3 times 3 gives you 9. X to the 1/2 times x to the 1/2 gives you x. Okay, now 3x to the 1/2 times -2 gives you -6 x to the 1/2. The first 2 times the second 3x to the 1/2 gives you plus 6x to the 1/2 minus 4. Okay, what's your last step here? Like terms. Okay, combine like terms. And in order to be like terms, you have the same what and the same what? Same base, same exponent. Good. Okay, so even if that exponent is a fraction. Okay, so the top, the numerator, you have 3x with no like terms. -2x to the 1/2 minus 6x to the 1/2 gives you -8x to the 1/2. Good. Plus the 4. All over 9x. The 6x to the 1/2 terms, they cancel each other out. See that? 9x minus 4. Okay. Now, I don't think this is ever going to happen. It shouldn't, but just in case it does, I want to make this point. The only way you can go through and cancel anything in that mess
Yep.
is if it happens in all 5 terms.
Okay. It only happens in 4.
Okay? It only happens in there's. I can see you taking the 4 out of 2 of them, or 3 of them, and a 3 out of 2 of them. Everybody see what I'm talking about?
Yeah.
The 4s with the 8s and the 3 and the 9. You can't do any of that because it doesn't happen in all 5. Okay? Has to happen in all 5 before you can do any of it.
That's gonna screw me over.
Okay?
I already know.
All right? You can't just go wham wham with the 4s. Has to happen everywhere. Okay? Your radical, or not your radical, see how your rational exponent got out of the denominator though? Okay, just like how if you would rationalize a square root kind of deal, that'd be your answer right there. Your homework is page 426, 16 through 48 evens.